Right. In this lesson, we are dealing with the laws of exponents, or sometimes it's called the law of indices. Laws of exponents or laws of indices. Before we look at those laws, however, we need to look at a term. Let's suppose we have 3x to the power 2. The 3 is called the coefficient. Three is called the coefficient. X is called the base. And 2 will be called the exponent, or sometimes it's called the power, or the index. So 3 is the coefficient, x is the base, and 2 is the exponent, the power, or the index. So we want to deal with laws that will help us to multiply terms of this kind. So let us look at our first rule. Our first rule is simply that terms of the same base, when multiplied, we add the exponents. For instance, if we have x to the power 3 times x to the power 4, the rule says if the bases are the same, and these two bases are the same because they're x's, if the bases are the same, we add the exponents, or add the index, or add the power. So it would be x to the 3 plus 4 would be x to the 7. So that's the first rule. Terms of the same base, when multiplied, we add the exponents. So if we have another example, x to the 3rd times x to the 4th times x to the 7th. So we just add. We said x to the 3 plus 4 is 7, plus 7 is 14. That would be x to the 14th power. So the rule is, terms of the same base, when multiplied, we add the exponents. So we can write a general rule that says if we have x to the n times x to the k is x to the n plus k, where n and k are numbers. So that's our first rule. Terms of the same base, when multiplied, we add the exponents. Let's look at the second rule. The second rule deals with division. It says, terms of the same base, when divided, we subtract the exponents. For instance, if we have x to the 12th divided by x to the 4th, those bases are the same, and we are multiplying. So we subtract the exponents. Terms of the same base, when divided, we subtract the exponents. Now this will give us x to the 12 minus 4. That's x to the 8. Because terms of the same base, when divided, we subtract the exponents. So if I have, say, x to the 3rd power times x to the 4th power times x divided by x to the 2nd power, x to the 3rd power, what we'll do in this case, we will simplify the numerator and simplify the denominator. Remember, by x we mean x to the 1st power, but we don't normally write 1. It's understood to be 1, but let's write it. So 3 plus 4 is 7, plus 1 is 8. That's x to the 8th power. And here we have 2 plus 3 is 5, so it's x to the 5th power. So here we use, in the numerator we use the first rule. In the denominator we also use the first rule. Now we use the second rule. Terms of the same base, when divided, we subtract the exponents. That is x to the 8th, take away 5, that's x to the 3rd power. So that's our second rule. Now, for our third, so that's a general second rule. X to the n divided by x to the k is x to the n minus k. N minus k. Right. So that's our second rule. Let's look at the third rule. A third rule. So we have our first rule, terms of the same base when multiplied, we add the exponents. The second rule, terms of the same base when divided, we subtract the exponents. The third rule states, if we have a base, say x, and that x is raised to the power, let's say 4, and the entire is raised to another power, let's say 3. We multiply the powers. We say x to the 4 times 3, which is x to the 12. And look why that has to be so. What does x to the 3 mean? To the power 3 means? Rather, x to the 4 to the power 3 means that x to the 4th times x to the 4th times x to the 4th. Because it's to the power 3, that means multiplied by itself 3 times. But look, we can go back to use the first rule. The first rule says, terms of the same base when multiplied, we add the exponents. So it's x to the 4 plus 4 plus 4, which is x to the 12th power. So you see it works. If you have a base raised to power, and then it's 4 raised to power, we can multiply the powers. And we don't have to expand it as we did here. We just multiply the powers. I did this to show that it's the same thing. We just multiply the powers in this case instead of expanding it. Okay, so those are our 3 rules. What if we have x to the 10th divided by x to the 10th? Let's see what that gives. X to the 10 divided by x to the 10th will be x to the 10 minus 10, which is x to the 0. Now, let's step aside from this. If we have a number, let's say 4, divided by itself, the result is 1. Any number divided by itself, the result is 1. So, x to the 10th divided by x to the 10th is a number divided by a number, so that would be 1. But we know here that x to the 10 divided by x to the 10th is x to the 0. So we can conclude from this that x to the 0 equals to 1. In fact, we can say any number raised to the power 0 is 1. Because raising a number to the power 0 is as if we say that number divided by itself. Like x to the 10 divided by x to the 10 is x to the 10 minus 10. Because of our second rule, terms of the same base, when divided we subtract the exponents. So we have x to the 0. But we can do it differently. We can say a number divided by itself is 1. So if this result gives 0, x to 0, and the same result gives x to the 1, it gets 1 rather, so x to 0 must be equal to 1. So we can say any number. Before that, let's write the third rule. X to the n times x to the k is x to the n times k. But let's write the rule now. Any number, say x, to the power 0, we take that to be 1. Because it is as if we are saying, in many ways, a number divided by itself. And a number divided by itself is 1. So, okay. So let us now maybe just work on a few problems. And then we'll deal with negative exponents. So let's work on a few problems. Suppose we have, let's combine them. X to the 4th times x to the 3rd times x to the 6th. Divided by x cubed. Let's see what we get here. We can say, in the numerator, x to the 4th plus 3 plus 6 over x to the third power. 69. So 4 plus 3 is 7. 7 plus 6 is 13. 4 plus 3 is 7. 7 plus 6 is 13. So it's x to the 13th power. Divided by x the third power, which is x to the 10th power. Or we can write it as 13 take away 3, which is x to the 10th. So what we did there, just combined the various rules. But look what we did. We worked out the numerator, then we simplify it. Suppose, however, we have this. Suppose we have a to the second power times a to the third power times b to the second power, b to the fourth power. What do we do there? Now remember, the rule says terms of the same base when multiplied, we add the exponents. So all we can do here is to say these bases are the same, so it's a to the 2 plus 3 multiplied by b to the 2 plus 4, 2 plus 4. So that would give us a to the 5th, because 2 plus 3 is 5, b to the 6th. Now we can't do anything further, because the rule talks about terms of the same base, and these are different bases. So they have to be left like that. Okay, they are different bases, so that we leave them as they are. So let's do just a few other problems. Suppose we have actual numbers. Suppose we have, I want to simplify or find the value of, let's say, 2 to the third power times 4 to the second power. What is that? Now 2 to the third power. Don't make the mistake, say it's 6. It is not. It's 8. Because 2 to the third power is 2 times 2 times 2, which is 2 to 4, 4 to 8. It's 8. And 4 to the second power is 16. That is 16. That is 16. That is 4 times 4. So we simplify that, and we got real numbers. Simplify, we got real numbers. So we can multiply now 16 times 8. 16 times 8. 8 6 is 48. 8 1 8 and 4 is 12. So that will give us, let's say 16 times 8 is 128. Let's do it again. 16 times 8. 8 6 is 48. 8 1 8 and 4 is 12. Right. So it's 128. So although we cannot say 2 today, well, we have to do 2 to the third power by itself and 2 to the fourth power by itself. And because these are real numbers, we can multiply them and get 128. Okay, so let's just do a recap. The first rule says terms of the same base, when multiplied, we add the exponents. That's rule 1. Second rule says terms of the same base, when divided, we subtract the exponents. Third rule, if a base is raised to a power and the entire is raised to another power, we multiply the powers. And we also saw that any number to the power 0 is 1. All right, so now I have a simple rule. I call it R cubed. And what I mean by that is that in order to understand mathematics, we need to record the information. It's the first R. We need to review the information. If we record and review, then we might remember the information.